Hello, in this video I will talk about trig integrals about secant and tangent. So I'm gonna focus on two problem type in this video. Say secant x to the nth, tangent x to the nth dx. M is even, or m and n they both odd numbers. Okay, so for example, when m is even, secant x squared tangent x cubed dx, or secant x fourth tangent x squared dx. Okay, so in this case, we want to focus on what secant carries an even power, what tangent carries cube or square, even or odd. We don't care that much. Second type is they both odd numbers. For example, secant cube tangent fifth. Something looks like this. Okay. Yeah, since the key formula is the same one for both problem type, so I put them together here. Okay. Want to make it clear, we are at the second problem category, these two problem type. Okay, which indicates secant data, or say secant x, and tangent x to the nth. Tangent and secant, they come together. So in the problem, you're gonna see both secant and tangent. Okay, for later, we're gonna see only secant case or only tangent case. The key formula here is secant x squared equals tangent x squared plus 1. Okay, we always want to use this formula. Let's see problems. Okay, I already put the key formula here. We're gonna use them. So the first case is when m is even. Secant is in this, when secant and tangent come together, secant is always our priority. We want to see what secant carries. Okay, so when you find it is an even power, what you want to do is you separate it into a even number plus 2. So this one I can rewrite into secant x squared tangent x fifth multiply secant x squared dx. Okay, so what I really want is here. And for this 2, I keep it secant squared with dx. And for the even part, here I separate out, use my formula, rewrite it into tangent. So which is tangent x squared plus 1. This is secant squared tangent x fifth secant x squared dx. Okay, and then substitution, u equals tangent x, du equals secant x squared dx, which is here. So plug in. I'm gonna go u squared plus 1 u to the fifth du, right? Multiply it in, separate it out, which is u to the 7th du plus u to the 5th du. Yes, and then this one equals 1 over 8 u to the 8th plus 1 over 6 u to the 6th plus c. And plug back your u, which is here, tangent 1 over 8 tangent x to the 8th plus 1 over 6 tangent x to the 6th plus c. Okay, so this is my final answer here. Okay, let's go back see our method. Firstly, I find secant is my priority. I want to see what it carries. 4, right? An even power. I want to separate it into even plus 2. So what I did here, secant square, I put it with the dx, these two, and then the rest part I rewrite it into key formula. Okay, I always use this formula as my key. Plug in substitution, you're gonna solve it. Okay, let's see next one. Again, I find secant carries an even power. Rewrite it into even plus 2, right? 2. So rewrite into secant x squared tangent x fourth secant x squared dx. What I want is here, put the squared with the dx, and then use my key formula to rewrite the secant. Tangent x squared plus 1 tangent x fourth secant x squared dx, which is substitution. U equals tangent x, du is secant x squared dx. Plug in, which equals u squared plus 1 u to the fourth du, which equals u to the 6th du plus u to the 4th du. Multiply it in, separate it out, and then equals 1 over 7 u to the 7th plus 1 over 5 u to the 5th plus c. And then you want to put the tangent back, 1 over 7 tangent x to the 7th plus 1 over 5 tangent x to the 5th plus c. And this is my answer. Same method, right? Exactly same method, so nothing too difficult. Just to remember, you want to separate out secant square. Okay, let's see the next one. So let's see the second problem type. M and N, they both odd numbers. Okay. You're gonna see problem like this: secant x cubed tangent fifth, or anyway, you see they both odd powers. The key formula is always this one. It's surely here, and the same way. You just rewrite it. You can rewrite it this way, but surely this formula. Let's see how we solve this. What you want to do is, once you say that both odd powers, you want to separate one secant x and one tangent x odd. Okay, so say this, you separate into secant square by 1 secant, and this one into tangent fourth by 1 secant. Oh, sorry, 1 tangent. So rewrite it into secant x square tangent x fourth by secant x tangent x dx. Okay, square 1 4 1. Okay, you want to separate out both of them. So what I want is actually this part, secant tangent dx. You remember, if say derivative of secant x equals secant x tangent x dx, which is this. So what I need to do is, I want to everything into secant so that I could use substitution, right? Find this part. Secant x squared. What I need to rewrite is actually here, tangent to the fourth, right? And here, tangent square equals secant x squared minus 1. This is tangent square, right? Fourth by copy secant x tangent x dx. Okay, so here u equals secant x, and then du is simply here, secant x tangent x dx. So I'm plug in, which is u squared minus 1 square du. Okay, and I need to multiply this out, which is u squared u first plus 1 minus 2u squared du, which is u to the 6 plus u squared minus 2u first du, which is multiply the u squared in 1/7 u to the 7th plus 1/3 u third minus 2 by 1/5. Let's see. Okay. So this is okay. Yes. What I need to do is plug in this u equals secant, right? So my final answer is 1/7 secant x to the 7th plus 1/3 secant x cubed minus 2/5 secant x to the 5th plus c. Okay, this is my final answer. Okay. I want to go back and see my method. It's pretty simple. As long as I find both secant and tangent, they carry odd power. I want to separate one secant and one tangent out. Whatever left, I just copy secant squared tangent first, okay? And rewrite the tangent into secant by using our key formula, which is here. There may be squared or just itself, secant squared minus 1. You just want to match up the power. And then substitution, u equals secant, plug in. You can solve it. Okay. Let's see the next problem. Okay. So here I'm gonna do the same thing. Rewrite it into secant squared tangent x squared by secant x tangent x dx. Okay. So I want everything into secant. I have to rewrite tangent square, right? Secant x squared. Tangent square equals secant x squared minus 1. Copy secant x tangent x dx. U equals minus 1. U equals secant x. Du is simply secant x tangent x dx. This one plug in u squared minus 1 by du. U first minus u squared du. A 1/5 u to the 5th minus 1/3 u cubed plus c. Plug in 1/5 secant x 5th minus 1/3 secant x cubed plus c. Okay, so this is my answer. Okay. I want to give a brief summary for this video. We did two problems, two problem tabs actually. All the problem falls into each tab. They just have one problem, right? Method is pretty fixing. When you see this, for example, a secant x squared tangent x cubed dx. Okay, I always want to see the secant as my priority. This could be odd or even, but surely secant carries an even. I'm gonna want a secant square, right? In this case, I don't need to split anything out because it's just a simply secant square. I can say u equals tangent x du gonna be secant x squared dx. Plug in, which is u cubed du. Okay. If I raise the power into 4, I want to separate it into a secant x squared by secant x squared tangent x cubed dx. Okay. So in this case, I raise the power on secant into 4, and then this part I want to come with the dx, and the rest part of secant you want to rewrite into tangent. So you can use substitution later. And the second problem type is they both odd numbers, which indicates the power here, both secant and tangent. And what you want to do is you want to separate out one secant and one tangent with the dx. It's just a derivative of the secant, so you want everything is priced by secant. Rewriting your tangent part and then use substitution. Okay, substitution with u equals secant. Okay, I wish you could find the difference between these two problem types. Here u equals tangent and here u equals secant. How it comes, what's gonna be your du. Okay, so I think it's pretty simple method as long as you're familiar with them, and wish this is helpful. So see you in my next video. Thank you. Bye bye.